back at it like a bad habit. What's good, peeps? It's your boy doing some maths once again. I know you're happy to see me. I know. We're doing another paper. So what I'm doing lately is I'm just doing papers. Just starting to get this ball rolling, putting out videos. And one way I see fit to do that is to run through some piss easy papers. I'm just kidding. Right. Okay. We're going to go through this. This is Cambridge again. A-level. Pure maths. Paper 1. Probably going to do like half of it. Take a break. Do the other half. May, June 2016. Hopefully I'm going to do all the papers. So I'm going to do May, June 2016. October, November 2016. And then do that for 2017, 2018. So I'll do that for all the pure maths ones, and then maybe all the some physics ones, or some other papers, or whatever I see, you know, looks kind of fun for me to do, and also that I think would be helpful for people out there. Let's crack into it. Question 1. Find the term independent of x in the expansion. Well, I've done a few papers now. I think I've released 3 papers. Well, I definitely released two pure maths papers on my channel. So I'm starting to see, you know, similarities, real similarities in these papers. And the pure maths ones is he asked the sort of the same questions, just worded a little differently. We're going to need this equation for the first one. So let's just write that out. You know, they usually have one like this. They usually have, you know, you can sort of see when you do more that, you know, there's not too much creativity going on with the exam writers. You know, they're just sort of, I wouldn't say repeating questions, but the questions are definitely similar. Yeah, and this goes on and on. And it says find the term independent of x in the expansion of this. So in our expansion of this, so our a will be x, and our b will be minus 3 over 2x, and n is 6. So independent of x, so this is just a constant term, so there's no x squared, no x cubed, there's none of that business in the term that we want to find. Well, if you think about it, we've got an x for our a, and then we've got an over, like 1 over x term sort of thing here for our b. So when we multiply the a and b part, these parts here, we're going to want the powers of a and b to be the same. And because n is 6, that'll occur when in this sum it'll occur with this term, n minus 3 and b 3, because that means it'll be a cubed and b cubed, and the x's will cancel. So if we just calculate this term, that gives us the independent term, independent of x term. You know, you could expand it all out if you wanted to, if you didn't want to, you know, if you don't believe me. But I'm telling you, this is what is going to happen. You know, the x's are going to cancel. I mean, it's pretty obvious. And that saves you a lot of time to answer this question. So the term that we care about is this one. And it's x to the n minus 3, 6 minus 3 is 3, times minus 3 over 2x to the power of 3. So we get 6, pick 3, which I'm going to guess like somewhere around 20 or something, 25 maybe. See if I see 3. 20 exactly. Pretty close. So this is 20 when you plug it in your calculator. times x cubed, and this is going to be minus 3 cubed is minus 27 over 8x cubed. Well, you can see that these are going to cancel. So we get 20 times negative 27 divided by 8. Okay, so we get negative 67.5. So it's negative 67.5. That's the term independent of x, so that's the answer. So the answer is this. Cool. Again, in the past 2 papers that I've released, there's always something kind of similar to this. We have to use your identities. So we have a 3 sine squared theta minus 4 cos theta plus 1 equals 0. So I just moved them over. And we want the solutions between theta between 0 and 360. So I'm thinking, well, I know that sine squared theta plus cos squared theta equals 1. So then we can write sine squared theta as 1 minus cos squared theta. So this becomes 1 minus cos squared theta minus 4 cos theta plus 1 equals 0. So then we get 3 minus 3 cos squared theta minus 4 cos theta plus 1 equals 0. Minus 3 cos squared theta minus 4 cos squared cos theta 3 plus 1 plus 4 equals 0, and then I'll just divide through by negative 1 to make it look pretty. And then we can do a substitution, and we can say that let's make our x equal cos theta, and this just becomes 3x squared plus 4x minus 4 equals 0, and that looks something a little easier, that we could find x. So we can use our quadratic formula. So our x equals minus b, which is minus 4, plus or minus the square root of b squared, which is 16, minus 4a, which is 3, times minus 4, divided by 2 times a, which is 3. So let's just simplify that using our calculator. Minus 4 times 3 times minus 4 is 48, plus 16. Okay, so we get, this becomes minus 4 plus or minus 8 divided by 2, so 6. So therefore we get 2 solutions of x. So we get minus 4 plus 8 divided by 6, which gives us 2 over 3. And we also get, or x equals minus 4 minus 8 divided by 6, which is negative 2. Negative 2. Okay, so those are 2 solutions of x, but remember that x, we made x equal, we introduced this variable x in order to solve this. Remember, our x equals cos theta, and we want the solution for theta. So clearly it can't be this one, because if we look at our cosine graph, it looks something like this, where this is 1 here, this is y equals cos theta, it's that line, and this is x, and then this part here is negative 1. So at no point does our cos of theta, at no point does this equal -2, because it only oscillates between 1 and -1. So at no point it equals -2. So this is impossible for it to ever equal -2. So we can just write off this -2 straight away. Now clearly if you look at the graph, it does equal 2/3. So 2/3 would roughly be about here. And we can see that it does have solutions. So there is a value. In fact, there will be two values in which cos theta equals 2/3. We can just mark in these points. We know that this here is 90 degrees. This is 180 degrees. And then this part here is 270 degrees. And then obviously at the end is 360 degrees. It's one oscillation. So we need to find out where it's 2/3. So we say cos theta equals 2/3. So we can find our theta. We just plug that into our calculator. So I get 48.2 degrees. So our theta equals 48.2 degrees. But also, you can see that between 0 and 360 degrees, there's not just one solution. So this solution here is 48.2 degrees. But there's also another solution here. So, which is, and because it's symmetric, so that means that the distance here is the same as the distance here, right? So it's going to be 270, right, 270, 48 point. So you're going to get another solution of, I feel like if we draw this bigger, it's kind of hard to see. I'll make it a little bigger. Why not? We got time. Long way. So we've got this graph here. So we found, so this is 2/3. And it's given us one of the solutions is 48.2 degrees. Probably looks more like up there, to be honest. I didn't want to do that. Oh well. So this is our 48.2 degrees at this point. So this is when cos theta equals 2/3. We also get another solution here. So we keep going across and we get another solution here. We know that this is 270 degrees. And because it's symmetric, that means that this distance here between this and 90 degrees is the same as this distance here to our second solution. So if we do 90 minus 48.2, we get 41.8. So then we do 360, we do 270 plus 41.8 is 300. So the second solution is 311.8. So we have two solutions. Hope that makes sense, right? Because it's symmetric. So this distance here, the amount of degrees between 48.2 and 90 is the same as the amount of degrees between 270 and our unknown second solution. So we can just add what the difference between 90 and 48.2 is to our 270 to get our second solution. And you can see that visually by the diagram of a cos theta. So we've got two solutions. Cool. Right. Let's continue. Question 3. The diagram shows part of a curve x equals 12 over y squared minus 2. The shaded region is bounded by the curve, the y-axis, and the lines y equals 1 and y equals 2. Show the necessary working to find the volume in terms of pi when the shaded region is rotated about the y-axis. We saw something similar, kind of similar to this in the previous paper that I did. And we figured out that, well, if we want to find a small dv, we need to look at, if we take a small tiny slice, probably going to be really bad at drawing this. Just pretend that's really, really small. If we take a small little slice with a height dy, remember this is tiny, 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 tiny. Whoa. If you take a small little slice, it'll be so tiny. I can't draw it small enough, but tiny, tiny, tiny. Then when we rotate this around the y-axis, like this, we rotate this around this y-axis, like this tiny little dy section. Then, remember this is at a height x, so whatever x, that point x is where we're taking our dy, so this is at a height x. If we rotate this tiny little slice, which remember would have an area, so this little dA has an area of, I explained this in the last video, of x dy, right? Just base times height. If we then rotate this round our y-axis, we then get a volume, like a circular disc, like a frisbee sort of volume, and that volume is going to equal to the area of that disc times that little dy, the width of the disc. So it's going to be pi r squared, in this case is x squared, because it's the height of the curve, or at the point x. They're trying to be tricky by switching the variables here, times our dy. So that's our small dv element when we rotate around the y-axis. So in order to find our total volume, we'll have to integrate this. So our total volume is summing up all of these discs, all of these circular discs, from 1 to 2. This equals the sum between of pi x squared dy. So I think my computer is running out of space or something, but cleared some space up. So we were up to this point where we found the equation to find the total volume of this. So our VT, our total volume, is equal to this of x squared, and this is, well, let's just work out our x squared first. Our x squared is just going to be this thing here squared, which is 12 over y squared minus 2 squared. So that equals 12 over y squared minus 2 times 12 over y squared minus 2. And that equals, well, that gives us 12 times this, 144 over y4 minus 2 times this one, so it's minus 48 over y squared plus 4. So this gives us our total volume equals, we can take the pi out because it's a constant, between 2 and 1 of this 144 over, well, we can write it in by bringing the exponents up, because that'll make it a lot easier for us to integrate it. Plus 4 dy. Well, and then we just integrate this, which gives us pi. You go up by a power, divide by the power, so we get minus 144 over, well, 144 minus 3 y negative 3 minus 48 y negative 1 over negative 1 plus 4y, well, 1 over 1, between 2 and 1. We just simplify that a bit more, and we get, well, 144 divided by negative 3 gives us negative 48. So this is negative 48, and then you can bring this back down, so we can say negative 48 over y cubed. Minus minus, so it's a plus, minus divided by a minus is a plus, 48 over y plus 4y between 2 and 1. So this gives us a total volume of pi times, when we substitute in 2, we get 48 over 2 cubed plus 48 over 2 plus 4 times 2 minus 48 over 1 plus 48 over 1. It's kind of redundant me writing these ones. And that just gives us pi of minus 48 divided by 8 is negative 6 plus 48, so it's 12 plus 12 plus 8. So this is 48 divided by 2 minus 48. So this is minus 6 plus 48 divided by 2 is 24 plus 4 times 2 is 8 minus 48 minus 48 plus 48 plus 4. So therefore our final total volume is going to be, well, negative 6 plus 24 plus 8 minus 4 gives us 22 times pi, which is 22 pi. So the answer, the total volume is 22 pi. Coolio! Okay, man, let's go. Let's do some more. Right. Question 4. So we have a curve. Dy by dx equals 2 minus 8 of 3x plus 4 to the negative a half. Look at that. Can we just appreciate that 2? That was meant. This was meant to be a 2. Like, what the fuck is that? Honestly. 2. A point P moves along the curve in such a way that the x-coordinate is increasing at a constant rate of 0.3 units per second. So our dx of dt, this is of our point P, equals 0.3. Find the rate of change of the y-coordinate as P crosses the y-axis. So we need to find dy by dt when P crosses the y-axis. Well, when this point crosses the y-axis, that occurs when x equals 0. This is y. So this is, we want dy by dt at x equals 0. What does that equal? Well, we can use the chain rule. So dy by dt equals dx by dt times dy by dx, and that will give us 0.3 times, and we want this, times 2 minus 8, 3x minus plus 4 to the negative a half. And we want this evaluated at when it crosses the y-axis, so when x equals 0. So when x equals 0, this is 0.3 times 2 minus 8. 3 times 0 is 0, so this is just 4 to to the negative a half, which equals, you can just plug that into your calculator, 4 to the power of negative a half times 8, 2 minus that, times 0.3. So you get the answer of negative 0.6. So dy by dt, sorry, equals a value at x equals 0 equals negative 0.6 II. The curve intersects the y-axis at y. Okay. So the point runs through, this tells me the point runs through x equals 0 and y equals 4 over 3. Okay? And then it wants us to find the equation of the curve. And we're given that dy by dx equals this. 2 minus, doesn't look like we have left myself that much space here, minus 8 we don't have a lot of space, so we'll just make some space here. Ooh. Okay, so we're all good with this, so I'll just rub this out. So now we're looking at II. Again, so it passes through the point 0, 4 over 3 and wants us to find the equation of the curve. Well, we're given this, so the equation of the curve we can find by integrating this. So we integrate this. So our y is going to equal to, and you can split this up because it's distributed, I think that's the word that mathematicians use. So you could say it's this. You can take this constant out as well, it's just a constant of 3x plus 4 to the negative a half dx. Well, this just equals, this just becomes 2x minus 8 times, well, this integrated is, again, the way you do this is a product of the chain rule, what we used before. And basically what you do is you go up by a power, divide by the power, so you're going to have 3x plus 4, go up by a power as a half, divide by a half, which is the same as timesing by 2. And then you also divide by this, whatever's in the brackets differentiated, which in this case is just 3. And if you don't know why that is, just look up the chain rule. The chain rule is really important. It's very fundamental to a lot of this stuff and why we do how we differentiate, basically. Okay, so that equals 2x minus 16 over 3 times the square root of 3x plus 4. So we have our y, but remember we have to plus c to this when we integrate, right? And I've talked about why that is before. Okay, and then, so we've got this equation, but now we need to find out what the c is. Well, we have a point on this curve, so if we just substitute that in, we can find out what c is. So if the point 0, 4 over 3, so we get 4 over 3 equals, well, that's just 0 minus 16 over 3, and the square root of 4 plus c. Then we can say we get 4 over 3 is minus 16 over 3 square root. Well, this is just times 2, this is 32 Yeah? So then we can say our C is, just do 4/3 plus 32/3. So our C is 12. So therefore, the final curve is this. It's kind of ugly, but that's what it is. So that's your final curve. Boom! 5. We'll do 6, 5, 6, and we'll do 5, 6, and 7, and then I'll do the rest later. But it'll be all in one video for you, so you know. I don't even know why I'm telling you that then. A farmer divides rectangular pieces of land into 8 equal-sized rectangular sheep pens, as shown in the diagram. Each sheep pen is X by Y. Fully enclosed, the farmer uses 480 meters of fencing. So the total number of fence used is 480. It's one specific farmer. This farmer must have done mathematics before. He's making some, you know, they're each exactly the same size. That's pretty impressive. Anyway, show that the total area of the land used for the sheep is this. Well, we know the area is just going to be this length times this length. So our area is going to be equal to, this is just 2y times, well, 1, 2, 3, 4x, which is just 8xy. But this is just in terms of x, so we need an expression that relates y and x. And we know that the total number of fencing is 480. So that means if we sum these all up, so you've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 10y. So 480 will equal 10y plus 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 plus 12y, x. So that's equal to, struggling to hold this pen, 2x. Okay, so now we can get an expression for y in terms of x. Well, let's just divide through by 10. 48 equals y plus 1.2x. So then our y equals 48 minus 1.2x. So therefore, our area is going to equal to 8x. On paper, I write my x's like this, which I think look nicer. But here, for some reason, I've tended to write it like this. 48 minus 1.2x. Let's try and write it like that. Anyway. 8 times 48, 384. And 8 times 1.2 will be minus 9.6. So this gives us 384x minus 9.6x squared. I did it again. Okay, so we've shown that there. Aye. Given that x and y can vary, find the dimensions of each sheep pen for where the value a is at the maximum. Well, this is going to kind of look like this because of the negative in front of the x squared. It's going to look something like this. So the maximum will be at the vertex. You could also just differentiate. So you could complete the square and find the vertex. That'll give you what x value makes a the maximum it's going to be. Or you could just say where the derivative of a with respect to x equals 0, because that's at the top as well. I'm just going to do it like this. So you got dA by dx equals 384 minus 9.6 times 2, 9.6 times 2, 19.2, 0.2x equals 0. So you get 19.2x equals 384. So your x equals 20. And then if you wanted to find the other dimension, the y dimension, you just can substitute it into this equation, the equation relating x to y. So therefore our y will equal to 40a minus 1.2 times 20, which equals 1.2 times 20, 24, 48 minus answer. So y is 24. So the dimensions of the pens is x equals 20 and y equals 24 for when a is max. So when the area of the pen is at its maximum is at these dimensions. You know, so it's kind of handy for the farmer, right? If he wants to maximize his land with a certain amount of given fencing, well, we did it for him. We showed him. We're like, this is if you want it maximized, and use these dimensions for each pen. Question 6. So we find the values of constant m for which the line y equals mx is tangent to the curve. So we have a line y equals mx, and we have a curve y equals 2x squared minus 4x plus 8. So we should first look at where they intercept. So they intercept where we just equate their y's. So therefore we get 2x squared minus mx minus 4x plus 8 equals 0. So we can just simplify that a little bit more. Get plus x of minus m plus 4 of x plus 8 equals 0. So if we have a look at this here, we're going to want to know where this line is tangent to this curve. So we have some curve, and then we want to find, doesn't always have to be straight, we want to find where this line is tangent to this curve. Yeah? So if you have some line and it's tangent, that means it's just touching. So it's got 1 point, and that's where the discriminant equals 0. So it's where the discriminant of this equals 0. And remember, there could be points at where this line, because when you're increasing m, you're increasing the gradient. So there could be another m in which it intersects at 2 points. There could also be another m down here where it doesn't intersect at all. And those would be where the discriminant is greater than 0. And this would be where the discriminant is less than 0. So there's no roots, and there's 2 roots, or there's 1 root. And you can see as you vary m, there's going to be 1 point, there's going to be a couple, maybe a few values of m, maybe it could touch at another point, in which, because you could have m here, and then you could also have an m here, which is tangent, or whatever. And the way we find that is we look at the discriminant and where it is equal to 0. And that makes sense, right? Because when we work out an equation, like if we have an equation like ax squared plus bx plus c equals 0, well, the way we work that out is we find this minus b plus or minus the square root of b squared minus 4ac, this quadratic formula, which you can prove. This can be proved. I mean, I could prove it right now, but I don't want to, so it'll take a little bit of time. But this can be proved that this is the solution from this. If you just complete the square of this, I'm pretty sure you can get to this. But when this thing equals 0, well, then you just have one solution, and it's this. Right? You have that one solution. When it's not equal to 0, well then you've got the plus and the minus, so you get 2 solutions. Yeah? And then when this is less than 0, well then you get no solutions, no real solutions. So this makes sense. Anyway, so let's look at so we've got an A of 2, a B of minus m plus 4, and a C of 8. So our discriminant is going to be this thing squared, which is just m plus 4 squared, minus 4ac, which is 8, where that equals 0. And so we can just work this out. We get m squared plus 4m plus 4 is 8m plus 16 minus 4 times 2 is 8, 64 equals 0. So therefore we get 16 minus 64 is minus 48. So we get m squared plus 8m minus 48 equals 0. So we look at what plus into that, which times is into that. Well, it's going to be negative 4 plus 12. Negative 4 times 12. So this is going to be, if we just factorize this, minus 4. And then m plus 12 equals 0. Okay? So we have two solutions, where m equals 4 or where m equals negative 12. So those two values for m is where the line touches the curve. Okay. bi. We have a function f of x equals x squared plus ax plus b. F of x equals x squared plus ax plus b. The solutions of the equation f of x are x equals 1 and x equals 9. Okay, so we have when f of x equals 0, well then x equals 1 and x equals 9. Okay, so that's 2 points that we have there. So find the values of a and b. Well, you can just substitute them in. Yeah, so let's look at this I here. We just substitute this in, we just substitute the points 0, 1 in and 0, 9. Then we're going to have two equations involving a and b, and then we can find out, if you have two equations involving two unknown variables, you can then find both of those variables. So this is 0 equals, and when we plug in 1, we get 1 plus a plus b. So we get a equals minus 1 minus b. So that's one equation. And then we also get 0 equals 9 squared is 81 plus 9x. Oh, 9a, sorry. 9a plus b. Yeah? So then we can work out, if we just plug in our a into this, we can then work out our b. So you've got 9 of minus 1 minus b. We're just substituting this into here. Plus b plus 81 equals 0. Well, this is minus 9 minus 9b plus b is minus 8b plus 81 equals 0. So you get 81 minus 9, 72 divided by 8, divided by negative 8. So you get divided by negative Did I do something wrong here? Hold up. Wait. So we get 9 squared. 9a plus b. So we have 9a plus b equals minus 81. And if we plug this in, we get minus 9 minus 9b plus b equals minus 81. So you get 8b minus 8b equals minus 72. So b equals 72 minus 72 divided by minus 8, which is 9. Okay. And then our a will equal minus 1 minus 9. So a equals minus 10. Yeah. So that's our a and b. And then the coordinates of the vertex of the curve y equals f of x. Okay, so what we have, let's just do this here, I. We just substitute these in, a and b. You get f of x equals x squared minus 10x plus 9. So we can rub this out. So now that we found our a and b, we have the equation of our curve. And we can just complete the square here, and we can say that, well, this is just equivalent as x minus 5 squared minus 5 squared plus 9, which equals x minus 5 squared minus 25 plus 9 is minus 16. So we have this, and the vertex point occurs when x equals 5. So when x equals 5, when x equals 5, y equals minus 16. Okay? So the vertex is at 5, negative 16. Cute. Right. We'll do this one, and then I'll do the rest some other time. In the diagram, AOB is a quarter circle with a center 0, radius r. Okay. So it says express the perimeter of the shaded region in terms of r, theta, and pi. Well, the perimeter of this shaded region is just made up of 3 different things. It's made up of CD plus CB, CD plus DB plus BC. So we can find each of these things, then we can find the perimeter. Well, this angle here is going to be pi over 2 minus theta. So that means that this angle here, these 3 angles have to sum up to 180. So pi equals this, pi over 2 minus theta, plus our pi over 2 here, plus our unknown angle here, which is, we'll just call it x. Well, that means that we get pi over 2 plus pi over 2 is pi. plus theta plus x is pi. So you get, oh, minus theta. So you get, well, these just, so you get theta equals x. So your x, so, and I'm pretty sure that's just, you know that anyway because of some rules like involving parallel lines where these, or something where these angles are the same. I can't really remember, but anyway, I just proved that just mathematically. So this is theta. I just proved that there. And if that's theta, well, that's going to help us a lot. So let's find these different things. Well, our CD here. So CD. Well, this is just the length CD, the length DB, and the length BC. So our CD length is just going to be, well, this is opposite, adjacent, and this is our hypotenuse in this right angle triangle here. So this length CD is going to be, so cos theta here is going to be adjacent, which is the length CD, so we'll just call it CD, divided by our hypotenuse, which is R. So therefore our CD equals R cos theta. And then the OD, this length here, is going to be the same, but it's going to be R sine theta. Right, so that means, so we can just write, so we know that sine theta equals OD over R. So therefore OD equals R sine theta. But we don't want OD, we want BD. And we know that this entire length, because it's the radius, this is like a quarter of a circle. Well, this entire length is R. So therefore DB equals R, which is this entire length, minus, so it's just OB, so this entire length, minus OD. Which is just R minus R sine theta. Cool, so we've got two components here. We've got CD equals R cos theta, psi, and we have DB equals R minus R sine theta. And then final thing we need is BC. Well, that's just, we can work that out through our arc length formula, which is just R theta. So this is the arc length, call it arc, which is something you're given. It's the arc length. And our R was just R, right? But the angle is this angle here, which we found before. It's just pi over 2 minus theta. So our BC is just going to equal R times our theta, and our theta in this case is just pi over 2 minus theta. Yeah? So, I think the music's finished. Wow, it's already been an hour. Been going pretty slowly. So therefore our BC is equal, therefore our perimeter is equal to all of these summed up. Cos theta plus R minus R sine theta plus R of pi over 2 minus theta. So that's your answer. Yeah. Cool. II. For the case where R equals 5 centimeters, R equals 5 centimeters and the angle is 0.6, find the area of the shaded region. Okay, well, the area of the shaded region is just the area of OCB. So this area of this, what do they call it again? Sector. So it's just the area of OCB. So let's just write it like this. So the area of the shaded region is equal to the area of OCB. So this whole thing minus the area of this triangle OCD. Minus the area of this triangle, the triangle OCD. So let's work these things out individually. Well, area of OCB is going to equal to a half. This is from your formula again. And it's an r squared again, but remember our theta is pi over 2 minus theta. So this is times pi over 2 minus theta. Yeah, so that's just that. And then the area of the OCD triangle is half base times height. And our base is OD, which is this. And our height is DC, which is this, which we've already calculated. So it's half base, which is, so it's r cos theta times r sine theta. So this equals half r squared cos theta sine theta. So therefore the area of the shaded region equals this minus this. So it's a half, so half r squared pi over 2 minus theta minus a half r squared sine theta cos theta. So that's your answer. That's your answer there. Okay, but then obviously you need to then sub these things in. So the area of the shaded region is going to equal to a half 5 squared, because your r is 5, of pi over 2 minus 0.6 minus a half 5 squared of sine of 0.6 and cos of 0.6. And if you just plug that all in, 5 squared divided by 2 times 12.5. So this part is 12.135 minus 5 squared of sine of 0.6 times cos of 0.6 times 25 divided by 2 and 12.135 minus answer. So I got 6.3. I forgot what this is, but the answer, the final answer, the shaded region is 6.31. Cool, and I'll continue with the rest of the questions later. Okay, yo. Let's continue this paper. Again, the technical difficulties continue, but we managed to get the mic working and the tablet working and the screen being recorded, so let's do these questions. Okay, so again we're doing, just to make sure I remember, we're doing this paper May, June 2016, pure maths. And we got up to question 7, and now we're going to do question 8, 9, 10, and 11. Okay. So let's just crack right into it. Let's crack right into it. Hopefully the mic's picking this up. If not, I'm going to be pretty disappointed. So we've got a curve. Y equals 3x minus 4x to the negative 1. I'm going to write it like that because I feel like we're going to have to differentiate in this. So it's nice to have it in an exponent form. And it passes through, this curve here passes through the points A, which is at 1, negative 1, and B, which is at 4, and 11. So it passes through those points. At each of the points C and D on the curve, the tangent is parallel to AB. Okay, so we have two more points. So let's say we have two more points, C and D, which also lie on this curve. And the tangent, I don't know how the hell this curve will look, but you got some curve and the tangent at these 2 points, so that means the gradient at these 2 points, C and D, which lie on the curve, are parallel to AB. So that means that they have the same gradient as AB. Right? So we have to find the equation of the perpendicular bisector of CD. Okay, so let's just think about this. Let's just think about where we got to go. So we've got to find the perpendicular bisector of CD. So all that means is that we have to find, so let's say you have C and D, these 2 points, and a line connecting them. The perpendicular bisector is the line passing through the midpoint, which is perpendicular to the line CD. So we've got to find this line here. And these 2 points lie on the curve. So in order to find that, we need to find the gradient of CD, because that will then give us the gradient of this line, the perpendicular bisector of CD. And we also need to find the midpoint of CD. And to do that, we need to find the points C and D. So we need 2 things. To find this perpendicular bisector, we need to find the points C and D. That's one thing we need to find. Another thing we need to find is we need to find the gradient of the line CD. We can just call it line CD or whatever. Okay? And we find those 2 things, then we can find the equation of the perpendicular bisector. Okay, so let's do that. How can we find, we know, first of all, we know that these points C and D lie on the curve. The tangent, and so their gradients is parallel to AB. So first of all, let's find the gradient of AB. So let's find the gradient of AB. So we have 2 points, so the gradient is going to be y2 minus y1. So we can just find it because it's a line. You know, you're connecting 2 points with a straight line. Well, this is just going to be, well, y2 here is 11, and y1 is negative 1. So you're minusing minus 1 over x2, which is 4, and x1, which is 1. So this is 11 minus 1, so it's 12 over 3, which equals 4. So the gradient, so therefore the gradient of AB equals 4. So that's an important piece of information, because that tells us that the gradient, because their tangent is parallel to AB, so that means that that the gradient at C and the gradient at D is the same as the gradient of the line AB. Cool. So therefore we can then find the points C and D, because we know that the gradient, so we know that the gradient of at points C and D, which remember lie on the curve, is 4. And how do we find the gradients at C and D? Well, we can just find the derivative of this curve, because they lie on the curve. So we have dy by dx equals, well, 3 minus, times down by the power, minus 1, go down a power, which is 4x to the negative 2. So this gives us 3 plus 4 over x squared. I don't want to get notifications. Okay. Right? So that's the dy by dx. So we want to know, so we know that those points have a gradient of 4. So we want to know where along the curve is the gradient of the curve equal to 4. Well, that's just whenever this equation here equals 4. And so if we solve this, we get 4 over, let's just do it over here. We get 4 over x squared. Take the 3 over, is 1. So then we get x squared equals 4, right? So we get an x equals plus or minus 2. So then the x coordinates of C and D are 2 and minus 2 respectively. And then we can find the y coordinates of those by just subbing it back into our... Oh, go away. By subbing it back into our equation. So we get y equals... What we get? 4 x equals 2. We get y equals 3, 2 minus 4 over 2, which equals 6 minus 2, which equals 4. And for x equals negative 2, we get y equals 3 times minus 2 minus 4 over negative 2. So this is minus 6 minus, so which is plus 2, which is minus 4. Cool, so then we've worked out these 2 points. So we can say C occurs at 2, 4, and D is at minus 2, minus 4. Okay, so then we can rub this out, because I haven't left myself enough space. So we'll just rub that out. So now we found C and D. And then we need to find the gradient of C and D. The gradient of CD. So m of CD, well, that's just going to equal 2. We have 2 points along this line, is y2 minus y1 over x2 minus x1, which equals y2, which is minus 4, minus y1, which is 4, over x2, which is minus 2, minus 2. So this is minus 8 divided by minus 4, which gives us 2. So that's the gradient of CD. And now, so we have our 2 points. So we found our C and we found our D, and we have a gradient. The gradient of this is MCD. So then that means that the gradient of our perpendicular bisector, so let's just call it M of our perpendicular bisector, is going to equal to minus 1/2, right? And then we need to now find this point here. So the midpoint of CD, the midpoint, let's just make it mid of CD, is going to equal to x2 plus x1 over 2 and y2 plus y1 over 2 of these 2 points, which in this case is, well, C x2, so it's 2 minus plus minus 2 over 2, and comma, well, 4 plus minus 4 over 2, which is just going to be 0, 0. So the midpoint of CD is this, and the gradient, okay, so we've got 2 things now. So we've got the midpoint of CD, and we have the gradient of our perpendicular bisector, which is minus 1/2. So we then have a point on that perpendicular bisector, which is 0, 0. And we also have the gradient of the perpendicular bisector. So therefore we can find the equation of the line, which is just going to be y equals, we can just sub it into your thing, But you can clearly just see it's going to be y equals minus 1/2 x plus 0, but there's nothing. Yeah, so that's the equation of your line. You know, if you have a line of gradient negative 1/2 and it passes through the point 0, 0, well, the equation of that line is just negative 1/2 x. So that's the equation of your perpendicular bisector, and that's the answer. Cool potatoes, cool beans, cool carrots. Okay, question 9. The first term of a geometric progression in which all the terms are positive is 50. The third term is 32. Find the sum to infinity of this progression. Well, let's just go on our equation sheet. And where's those? Geometric here. Oh, geometric is here. And our sum to infinity is a over 1 minus r. So our sum to infinity is a, which remember is just our first term, so we'll just call it u1, over 1 minus r. So we need to find two things in which all the terms are positive. The third term is 32, find the sum to infinity. So we need to find u1, our first term, and r. If we go to our equation sheet, we also know that this equation here, un equals a. Oh, we're given the first term, sorry. The first term is 50. Oh no, the first term we're producing in which all the terms are positive is 50. Okay, so u1 equals 50. And then our r, well, we can find, we have un equals, what was it again? A, so rn minus 1. So u1 rn minus 1. So therefore, u3, and I'm using u3 is because we're given u3, equals u1 of r times n minus 1, well 3 is 3 minus 1, which is 2. So u3 is 32, u1 is 50, r squared. So then we get r squared equals 50 divided by 32. Where's my calculator? 32 divided by 50, which is 0.64. 64. So therefore r is going to equal to plus or minus, well, it's going to be plus or minus 0.8. But our r can't be minus 0.8 because all of the terms are positive. So r has to be positive as well. Otherwise it would just fluctuate between positive and negative. But we want all the terms to be positive. So our r is in fact 0.8. So therefore we can find our sum to infinity, which is going to be 50 divided by 1 minus 0.8, which is 50 divided by 0.2. 50 divided by 0.2 is 250. So our sum to infinity. When I haven't written on this thing before, it takes me a while to get used to it. I feel like I can't write, you know, like properly. Cool, so that's A. B. The first the terms of an arithmetic progression are 2 sine x, 3 cos x, and respectively. So let's just write that out. u1 equals 2 sine x. u2 equals 3 cos x. and u3 equals sine x plus 2 cos x. u3 equals sine x plus 2 cos x plus 2 cos x, where x is an acute angle. Okay. Show that tan of x is 4/3. Well, immediately the way that I'm thinking to do that is, well, what do we know about arithmetic progressions? Well, we'll know that the differences between progressive terms, so u1 and u2, the difference between u2 and u1 is the same as the difference between u3 and u2, which is the same as the difference between u4 and u3. Like there's a constant difference between each term, increasing term. So I know that because it's arithmetic, the u1 minus u2 equals u3 minus u2. Right? And so this is 3 cos of x minus 2 sine of x equals u3, which is sine x plus 2 cos x, minus u2, which is 3 cos of x. So this becomes 3 cos of x minus 2 sine of x equals sine of x minus cos of x. So then we take this over, we get a 4 cos of x. We take this over, we get a 3 sine of x. So then you can see here that you get 4 equals 3 sine of x over cos of x. So therefore 4/3 equals sine of x over cos of x, which equals tan of x. So therefore we've shown there that tan of x equals 4/3. And that was I. And then there's another one, I. Okay, I. Find the sum of the first 20 terms of the progression. So I. So we need to find S20. And if we go to our equation sheet, Sn equals half n 2a n minus 1d. So this equals a half n. There, I forgot it. Of 2a n minus 1d. 2u1 plus n minus 1d. That's so gross. Let's see if we can draw that better. Oh, that was nice. That was a nice one. Let's make sure that's right. Okay, cool. So to find S of 20, all you have to do is find U1 and D. Well, U1, well, first of all, we know that X equals, why is it lagging? X equals tan of, we know that X equals, from here, inverse tan -1 of 4/3. So let's just work out these things. So U1 is going to equal to, and that'll be, that'll be approximately, shift tan of 4/3. It's approximately 53.13 degrees. Whoa. 0.13 degrees. So our U1, which is 2 sine of x, is just going to be 2 sine, where's my sine? sign of answer, which is 1.6. So you just plug these things in, you get 1.6 here. And the difference, well, we could just find, let's find U2 as well then. U2 is 3. 3 cos of answer, which is 1.8. So therefore the difference between, you know, terms is 1.8 minus 1.6, which equals 0.2. So we have the difference and we have U1. So therefore S20 equals a half of 20 times 2 times 1.6 plus 19 times 0.2. So you get 2 times, well, 19 times 0.2 plus 2 times 1.6 equals 7 times 10 is 70. So your answer is 70. So it's just a matter of substituting those things in. Okay. Question 10. And then question 11, and we're finished. And then I'll upload this. Question 10. Okay, so we've got a few vector Roonies here. OB is equal to 5 minus 1k, where k is a constant, and OC is equal to 2, 6, negative 3. So find the value of k in the case where the angle AOB is 90. Okay, so we have to use that. Seems like they always ask you a question like this. OAB, and the angle here, well, this is 90 degrees in this one. We have to use the cosine rule, which just says that the cosine theta, the angle between these two vectors, is OA dot OB over the magnitude of these vectors multiplied together. So if we just work out these things, so OA dotted with OB equals 2, 1, negative 2 dot with 5, negative 1k, which gives us 10 minus 1 minus 2k, which is 9 minus 2k. And then we can find also, so that's what we're trying to look for. We can also find that OA is equal to, well, first of all, actually, you know, you can just see, you don't even need to work this out because you know that cos of 90 degrees is 0. Because when you look at the graph of cos, you know, this is at 90 degrees and that's just 0. So you're just going to get 0 equals 9 minus 2k over whatever stuff this is here. But when you just times this across, it's going to be 0. So you're just going to get 0 equals 9 minus 2k, which gives you 2k equals 9. So k equals 4.5. Cool. So that's I. Find the possible values of k for which the length of AB and OC are equal. Okay, well then you just got to calculate the length of AB and the length of OC and then equate them. So AB is equal to OB minus OA, which is equal to 5, negative 1k, 5, negative 1k, minus 2, 1, negative 2, 2, 2, 1, negative 2, which gives us 5 minus 2 is 3, minus 1 minus 2 is minus 2, and k minus is k plus 2. And so the magnitude of this is equal to the square root of 9 plus 4 plus k plus 2 squared. We'll just simplify that a bit and we get 13 plus k plus 2 squared. And then the magnitude of OC is equal to, we just look at our thing, well it's 4 plus 36 plus 9. Square root of 4 plus 36 plus 9, which equals the square root of 49, which equals 7. So then we equate these two to find our possible values of k, which gives us 7 equals the square root of 13 plus k plus 2 squared, square, so you get 49 equals 13 of k plus k plus 2 squared. So that means you get 36 equals k plus 2. So you get k plus 2 equals plus or minus 6, which gives us k could equal 4, or k could equal minus 8. And that's your answer. And I got no room for the next question. Well, I guess that means we just can't do it, right? Just kidding, we'll do it. Just kidding. Don't worry. I know you guys were like worried that, oh my god, is he not going to do it? I'll do it, don't worry. We'll do it, don't worry. I'll just rub that out. Okay, so that's the answer for that one. We'll rub this stuff out and we'll do the next one. I hope you don't need that for the next one. Rubbing out stuff is so satisfying. I could honestly just sit here all day and just rub this out. That sounds wrong. Okay, I'll get rid of this as well. Okay, cool, so we did that, and we got k equals 4 and k equals minus 8 for that one. The point D is such that OD is in the same direction as OA and has magnitude of 9 units. The point E is such that the same direction as O. Okay, so we've got OD is in same direction as OA, and OA equals 2, 1, negative 2, 2, 1, negative 2, and we have what was it? OE is in the same direction of, and has a magnitude of 9 units. So the point D is such that OD in the same direction has a magnitude of 9. Okay, and we also know that OD equals 9, the magnitude, and OE is in the same direction as OC, and OC is 2, 6, negative 3. 2, 6, negative 3, and this has a magnitude of 14. 14 units. 14 what? 14 fish? 14 monkeys? 14 plank lengths? Like, I need some clarity here. 14 what? Please tell me. 14 Jacobs? I don't think anyone wants to see that. 14 Jacobs? 14 of me? I don't want to see it. I don't want to see it, man. It's just not good for humanity. Find the magnitude of DE in the form of square root of M. Okay. Well, DE, first of all, DE is just OE minus OD. So we find OE and we find OD, then would you know it? we get DE, and then we can find the magnitude. Well, if OD is in the same direction, so if you have some vector OD, right, and it's in the OD, and it's in the same direction as some other vector, let's say OA here, well then it's just a scalar multiple of that direction. So we can say that OD is just some constant multiplied by this direction. Because remember, these numbers here are just a direction in three-dimensional space. So you have you go 2 in the x direction, 1 in the y direction, and -2 in the z direction. That's just some vector pointing in three-dimensional space. And if we say we have another vector pointing in the exact same direction, well, it's just going to be pointing, but it can be scaled, because it might not be the exact same vector. It might not be exactly the same as OA, but it could be scaled. It could be smaller, it could be larger, like we don't know. So you can say that, well, OD equals some scalar, some value which we don't know, times 2, 1, -2. Right? Oh, that feels so good. I guess so we could then find, and if our magnitude of OD equals 9, well then we can just say that 9 equals that, and then work out n, I guess we could do that. Is there a quicker way of doing it? Probably not. Okay, so then this is just 2n 1 minus 2. So we're just looking for this scale factor, and if we find the scale factor, then we can find OD. Right? So if we say, so we know this, well then we know that OD equals this thing. So which is 4n squared plus n squared plus 4n squared, which equals the square root of 4, so that's 9, square root of 9n squared, which is just 3n. So then we can find our n for this case, which is 9 equals 3n. So therefore our n equals 3. We can call it n1. So I've got no space. So therefore our OD equals this thing times 3. So it's 3 times this, so it's just 6, 2 minus 6. And remember, if you just factor out a 3, you can see it's going to be in the same direction. And then we can do the same thing for our so we found our OD, and then we can do the same thing for OE. Well, OE is just going to equal to some, we'll call it N2, some constant times the direction of times OC, and our OC is just this, 2, 6 minus 3. Well, once again, we know that OE is equal to 14, and that also equals, well, let's just call it n again, is equal to this thing, so it's just 4n squared plus 36n squared plus 9n squared. And remember, this equals 14, as given above. So therefore we get 14 equals 49n squared, which equals 7n. So n equals 2 for this case. So therefore OE is going to equal to 2 times this, which is 4, 12 minus 6. So then we can then find, because now we found our OE and our OD, then we can find our DE, which is just going to equal to 412 minus 6. What does it want, the magnitude? What's the magnitude? Okay. Minus 6, 2 minus 6. 6, 2 minus 6. And that gives us 4 minus 6 is 2. 12 minus 2 is 10. And minus 6 minus minus 6 is 0. Right. Yeah, everything seems to be correct. OE. Okay, so then you get DE equals the square root of 4 plus 100. So is the square root of 104? Is it not? I'm pretty sure I saw somewhere that this was like square root of 80 something. I don't know. Maybe I did something wrong. Because like before I look at this, like I don't go through the paper, but I look at, like I just look at the answers, like I have a gaze at the answers. And like, I'm pretty sure it was like the square root of 80 something. So maybe I've done something wrong here. 14, so 2 times this is 412 minus 6. 412 minus 6. And the other one was 3 times this. OD was, let's just do this quickly again. So is 4n squared plus n squared plus 4n squared. Square root is 3n. So then 9 equals 3n. So n equals 3. So then 3 times this. 3 times this is 6. Ah, that's why. So when I do 3 times 1 is 3, not minus 3. So this is 9. So then you get 4 plus 81, which is 85, which looks something more like, it's got an 8 in it, which is promising. Which is, I should remember, some sort of 8. Okay. DE. There's that. I love making stupid mistakes. It feels great. Okay, last one. We have a function f of x, which is defined by 4 sine of x minus 1, and it's between minus pi over 2 and pi over 2. State the range. Well, the range is just, you know, what values does f of x take. Well, we'll just sub these values in to see, because this is, we're going from minus pi over 2 to pi over 2. Well, f of minus pi over 2 equals 4 sine of minus pi over 2 minus 1, which equals sine, well, I know that sine of minus 90 is just minus 1. So you get 4 times minus 1, which equals minus 5. And then you do the same for f of pi over 2. And that gives you 4 of sine of pi over 2 minus 1, which is 4 times 1 minus 1, which is 3. So therefore our range goes from minus 5 f of x to 3. So that's I. Find the coordinates of the points where the curve y intersects the coordinate axis. So where does it intersect It's going to look something like this, right? Pi over 2 minus pi over 2. So where does it intersect these two things here? And it looks like this because we're shifting it down 1. Okay, so it intersects there where f of x equals 0. And that happens when 4 sine of x minus 1 equals 0. So then we get 4 sine of x equals 1. So sine of x equals 1/4. So where x equals so where x equals y equals 0, or x equals, so that means this point here is 14.5 degrees. Is that what it was? 14.5 degrees? Well, that's 14.5 degrees. And when x equals 0, we get y equals, so you get y, I don't know, I think this is what it wants. That, and then you also get when x equals 0, we get y equals 4 sine of 0 minus 1. Well, sine of 0 is 0, so you get y equals minus 1. So this is at the point 0 minus 1, and this is at the point 14.5 degrees. What in radians you can change it, 0. I. Sketch the graph of y equals f of x. Well, the amplitude is 4, and we're shifting it down minus 1. So you can always just look at these things. If you look at a sine graph, if this is y equals sine of x, well then what is y equals sine of x minus 1? What is that? Well, we're just shifting it down 1. So this is going to be, this graph here is going to be, it's just shifted it down 1. So instead of intersecting here at 0, it intersects at minus 1. So we get something like this. Right? And then if we times it by 4, well, instead of going up to 1 and down to minus 1, it goes up to 4 and down to minus 4. So our final graph is going to look like y equals 4 sine of x minus 1. And remember, it's between minus pi over 2x and pi over 2. So this is going to look like this. This is our x and this is our y. It's going to pass through this point here, minus 1. Like this. This is pi over 2. This is minus pi over 2. And if it goes down 4 here, that means this here is minus 5. And it goes up 4 here, well that means this here is 3. So that's your graph. Last one. Obtaining expression for the inverse of f of x and state the domain and range. We have f of x equals 4 sine x minus 1. So f of x minus plus 1 over 4 equals sine x. So therefore our x equals right, so this one takes us from f of x to x, and our inverse of x takes us from x to f of x. So we can say that the inverse of f of x is equal to sine of -1 of x plus 1 over 4. And if our inverse of f of x takes us from x to f of x, and our f of x takes us from f of x to x, well, that means that the domain of f of x is the range of the inverse of f of x, and vice versa. So the range of f of x is the domain of the inverse of f of x. So for this, our inverse function, our x will go from what our range of f of x goes from. So our range of f of x is -5 to 3. So our domain is -5 to 3. You can test this out, and that means that our range of this, that means our inverse f of x goes like this. Yep, that makes a lot of sense to me. That's it. Thanks for watching. I'll probably do another one soon. And if you liked the video, hit the like button. And peace out. See you later.